Good afternoon, everyone. I welcome you back to my YouTube channel, and presenting before you this wonderful tutorial is your mentor Hampio Kliman. And we're back again in the studio, and we are here to teach you something very interesting, and we are gonna go through set theorem. Now, I'm going to make this topic very simple for you so that you'll be able to understand almost everything that you want to know about set theorem. Let's get started. What is a set? Well, guys, we all know that a set by definition is a list, or let me just call it a list or a collection. Okay, so it's a list, or we can just call it a collection of well-defined objects. Okay, it's just a list of or a collection of well-defined objects. So the keyword is a list, then a collection, and of course we need to have something that needs to have well-defined objects. Now, one thing that you need to understand is that there are certain rules that we follow under set theorem. Sets are represented, let me just write that point. Sets are represented by big letters. So we use big letters when representing sets. But at the same time, we use small letters to represent the members of that set. Okay? So we use small letters to represent a set, to represent the members of a set, to represent, let me just say the members of a set. For example, A is a set, but small letter a is a member of set A, implying that A is a member of big letter A. A, of course, is being found in set A. The same thing can apply if you have this particular set and you name this set by a big letter. What you are implying is this set B is the main carrier, or let me just call it as a set, implying it to be the main set, but B, small letter b, is the member of this particular set. But if A happens to be not a member of set A, then we say that A is not a member of set A. The same thing applies here. If B is not a member of set B, then we say that B is not a member of set B. Okay? So this is what you're supposed to know. Okay? Now, the elements that are found in these sets, they are separated by commas and they are enclosed in what we call brackets. Okay? So they are separated. They are separated by commas and enclosed by brackets. It's very important to note that. All right. Let's get to talk about the methods that we use when describing the sets. Methods used to describe a given set. Well, there are two special methods that we use. The first method is called the roster or listing method. Okay? Don't forget that. Now, what about this method? From the word roster or listing method, automatically you know that you'll be listing some members of the set. So, if A is a set, and such that A is some set that contains the members A, let me just say the vowels, let's say A, E, O, U. If these are the members of set A, then they have to be separated by commas. By separating them by commas, you have just listed the members of set A. Therefore, that is how the roster or listing method applies. The second method is called the rule method or set builder notation. Set builder notation. Well, set builder notation is also very simple. So if you have some set B, of course, you would want to say that set B is equal to some x such that x is greater than or equal to 0 and such that x is a member of all natural numbers. Okay, you'd put it like that. Okay, or if, for example, you have been given a question such that you have, let's say, 2x equal to, let's say you have been given a 4. Well, this is a very simple mathematics. We know that we just cancel there and we just cancel there. And our final answer will be 2. How do we write that in set builder notation? Well, if x is a letter or a member of set B, then B is going to be written like this. This letter x is such that this x is going to equal to, okay, and that this same x is a member of, let me just say, even numbers. Why am I saying even numbers? Because 2 is an even number. So what I'm trying to say here is that set builder notation, they make the work become easy. Instead of lengthening the work, they make the work become very, very easy. All right. Let me just try to get rid of that. Now, let's proceed. Let's try to look at what we call the Affinity and Infinity set. Affinity and Infinity set. Okay, let me name this A. Now, a set is said to be finity if it contains a finite number of elements. A very good example is, for example, if you have been given set A, such that A contains the letters, let's just say A, B, C, D. The number of elements in set A is 1, 2, 3, 4. 4 is a countable number. That makes this set become finity. A very good example that I can also give is, given B, we say this is Monday, Tuesday, Wednesday, Thursday. Okay, we know these are weeks. Well, we know that B contains 7 weeks. Let me just say 7 days. There are 7 days in a week. Okay. So there are 7 days in a week. So these are countable numbers. But when it comes to an infinity set, it becomes different because, let's give an example of A. We may say that A, imagine if we say that A is a set of the number of, let me just say, sand particles on Earth. Well, you can't count sand, so this becomes an infinity set. Another good example is why we say B is equal to, let's give an example of, we can give an example of animals. Well, you can't count the number of animals on Earth. Animals keep on reproducing. These are infinity sets. So, in other words, a set is said to be infinity if it contains an uncountable number of particles. Let me just say of members. So, if you are given a set which looks like this, sometimes they'll put 2, 4, 6, 8, then they'll put this. What this means, they mean that the set continues like that. So this automatically makes it an infinity set. All right, that's very, very simple to understand. Okay, we now look at what we call the empty set. Sorry. Okay, so the empty set is represented by this symbol. You see something like this, or they will put something like that. So the empty set signifies a set which does not contain anything. Okay, so a very good example is if you have A, such that A is some set, and there is nothing in A, then this makes A empty. Okay, at the same time, if B is a set and this set contains nothing, then automatically B is an empty set. You may use this symbol to represent an empty set, or you can use this symbol to represent an empty set. They are just one and the same thing. Let's look at an example. Okay, so a very good example is, for example, if you are given, let's say A, let's say let A equal to this particular set, where they say x is such that x squared is equal to some 4, such that x is odd. Okay, so they've given this question in a set building notation, and they want you to try out that to figure out whether the set holds. So what we do here is very simple. This is what we're going to do. The first thing to do is to get your set that you have been given, the members of the set that you have been given. So of course we know that we have x to the power 2. We can solve for x like this, and of course we know that we are going to get 2 and negative 2. Now 2 and negative 2 are, let me just say 2 is an even number. Okay, so you discover that there is no odd number in this particular set. Therefore A does not contain anything that has to do with odd numbers. Therefore it becomes an empty set. Okay, so it's very, very important to really understand what it means. Let me make a very critical statement. The empty set is considered to be finity. Okay, you need to remember that statement, that an empty set is always considered to be finity. So there is nothing that you can count here. The fact that you make that statement, that means, of course, it makes it finity. Okay, it's always a rule. So make sure that you get to understand what that really means. All right. So these are very, very simple things to really understand. Okay, so we now move to what we're calling as, how about if you have been given a set of this kind? What is a singleton set? From the word single, it means it's a set that only contains one particular element. So if A is a set such that A contains the even number 2, then A is said to be a singleton set. Okay, because it contains only one figure. If B is some set such that B contains the letter A, B is a singleton set because it contains only one element. If C is some set such that C contains A and B, C is not a singleton set because C contains more than one number. Very important to understand. Okay. Very, very important to understand. We now get to what we call the subset. Let me just try to do it here. Subset, superset. So subset superset. A set is a subset of set B, or equivalently B is a subset of A. Okay, that is if all the elements that are in set A belongs to B. So A is a subset of set B, or equivalently B being the subset of set A, that is if all the members in A, okay, if all the members in A are in B. So if this is my set and I name it A, and this is my set and I name it B, if A contains A, B, and C, and this contains A, B, C, D, E, then I will say that A is a subset of set B. Okay? That is very, very important. Okay? That is very important to understand. So I'm just giving you these basics so that you'll be able to really grasp on that before we get to answer questions. Now, let's try to consider something, an example. Okay, let's have an example here. Let's assume that A is particularly this type of a set, and okay, and this set continues to be like that. And this contains, let me just say we have B, and B is some set that such that it contains 5, let's say 10, 15, and 20. And of course it continues like that. C is a set such that X is such that X, alright, let me just try to wrap something. Okay, X is greater than 2, and that X is prime. This is the set that we have been given. Now we want to show that A is a subset of B. So if you check, you discover that A contains these numbers, but these numbers don't really seem to appear in B. But C, the conditions are that C contains numbers that are above 2, and these numbers are prime numbers. Okay, so in this case, it so applies that C is a subset of A, because A contains prime numbers, and this condition applies. Do you see that? So the fact that the condition applies, this simply means that C is going to be considered a member, so a subset of A. And this makes sense. Okay? But A is not a subset of B, because what is in A is not actually what is in B. It's very, very important to understand that concept. All right, let's try to look at equivalent sets, equal sets. They're just one and the same thing. When is a set said to be equal? When you say equal, or we just say equivalent sets. Equivalent. If A is some set such that it contains the members A, B, C, and B is some set such that it contains the members, let me just say A, okay, B, C as well. So if all the members that are in A are the same members that are in B, and all the members in B are the same members in A, we say that A is equal to B. Okay? A is equal to B. And at the same time, we use these symbols to simply show equivalence. If, let's say, we assume we have A, okay, we put A, B, C, then in set B we can put, how about if, okay, let me just try to put some other letter. Then I put D. It is not true because this doesn't hold. A is not equal to B. Why? Because what is in A is not really what is in B. Take note of that. It's very, very important. So these concepts, they really help you to really understand more about sets. So today we'll try to end here, but I'm going to bring you more. The next time we meet, I'm going to teach you on proper sets, proper subsets, and because we're just doing a basic introduction to sets, but we are going to learn more. Thank you so much, guys. I love you so much. Keep on subscribing and learning, and more is yet to come. Thank you so much.